Up to now, we've primarily worked on solving systems of equations by using substitution method, where we solve for one variable, substitute in that variable, solve for the other variable, and then go back and solve for the first variable again. In this method, we're going to do what's called elimination. The methods algebraically aren't all that different. They're doing essentially the same thing. They're just doing it in a different way with a different pattern. Let's look at an example. 2x plus 5y equals 17. 6x minus 5y equals negative 9. I'm going to pause here and point out a few things. First off, notice I've organized everything in this almost large addition or subtraction problem setup, so that my x's are on top of my x's, my y's are on top of my y's, and my constants are on top of my constants. I also like working in standard form, xy constant, xy equals constant, so on and so forth, because I feel like that's just a nice way to maintain that setup. Okay, so look to do that. When you set up these problems, these elimination method problems, set them up vertically like this, and line up your x's, line up your y's, line up your equal sign, line up your constants. Then we're going to choose one of two operations, either addition or subtraction. And we're going to choose based on how we can best eliminate a variable. So let's first look at our x's. If I add or subtract these two values, are they going to eliminate? No. If I subtract, I'm going to end up with negative 4x. If I add, I'm going to have 8x. So in neither case does it eliminate x altogether. However, looking over here, I notice that I have positive 5y and negative 5y. If I add these two values together, I'm going to get 0y, thus eliminating this variable. So I'm going to choose addition for this one. 2x and 6x gives me 8x. I'm just doing this like one big addition problem. 5y plus negative 5y gives me 0y equals 17 plus negative 9 gives me 8. So now I simplify that, the y goes away and I get 8x equals 8, or x equals 1 after I do division property of equality. So that's how I solve using the elimination method for one variable. Now once you've done it for the one variable, we have x, we need to go back and solve for y using one of these two equations. Doesn't matter which one. I'm going to choose the first equation. 2 times 1 plus 5y equals 17. 2 plus 5y equals 17. Subtracting 2 from both sides. 5y equals 15. Y equals 3 after the division property of equality again. So now I have my answer 1, 3 is the solution to this system. That's just a different method for solving systems of equation. We're going to look at a couple of different examples of that. Here's another example. Negative 2x plus 15y equals negative 32. 7x minus 5y equals 17. Notice in this example, my x's aren't going to cancel out whether I add or subtract. My y's aren't going to cancel out whether I add or subtract. We don't really care about the constants. Them canceling out doesn't help us at all. So if that's the truth, then we've got a problem, right? Because elimination method isn't going to work right away. We're going to have to manipulate one of these two equations. So what I'm going to do is I'm going to look for some common factors. 2 and 7 don't have any common factors, but 5 and 15 do. They both have a factor of 5. So if I were to multiply 5 by 3, I would get 15. Okay, so I'm going to go through that process. I'm going to multiply this whole bottom equation by 3. So my first equation stays the same. Negative 2x plus 15y equals negative 32. My bottom equation, however, changes to 21x minus 15y equals 51. Now I can combine these two equations, and I'm going to use addition again because I want these two middle terms here to cancel out. 21x plus negative 2x gives me 19x plus 0y equals 19. 19x equals 19, divide by 19, divide by 19, x equals 1. Once again, once you have one variable, you plug back into the other equation. We'll use our top equation here. Negative 2 times 1 plus 15y equals negative 32. Negative 2 plus 15y equals negative 32. Add 2, 15y equals negative 30, y equals negative 2. 1, negative 2 is our answer. So in some cases, you're going to have to manipulate one of the equations to allow for canceling out. In some instances, you're going to have to actually manipulate both equations to cause anything to cancel out. Notice in this equation, I don't really have anything that's going to cancel out with common factors. So I'm going to have to sort of multiply both equations by something. And in this case, I can choose either equation, either variable to multiply by, whichever one I'm going to think is easier. I could do this one and make them both 12. I can do this one and make them both 6. By the way, I'm picking those numbers because those are the least common multiples. They're the easiest numbers for me to get both numbers to. Just to change it up, let's deal with the x variable in this case. So I'll multiply this whole equation by 4, this whole equation by 3, giving me 12x plus 8y equals 4, 12x plus 9y equals negative 6. And in this time, I'm going to subtract the two equations because notice the two things I want to eliminate have the same sign initially. So they're not going to cancel out if I add them. So to cancel them out, I'm going to have to subtract them. So I subtract them, and I get 0x, 8 minus 9y gives me negative 1y equals 4 minus negative 6. So minus negative is addition, gives me 10. So y, therefore, must equal negative 10. If that's the case, I can plug back into either one of my variables, either one of my equations, plus 2 times negative 10 equals 1, 3x minus 20 equals 1. Add 20 to both sides, 3x equals 21, divide by 3, x therefore must equal 7. And our solution is 7, negative 10. And that's elimination method. So it's just a different approach from what we've been doing with substitution. And tonight you're really going to focus on using elimination method for everything. As a reminder, remember that if a system comes up with an untrue statement at the end, right, something like 0 equals 15, there's no solution for that. Okay? If you go through this process and you end up with something like 0 equals 0, 15 equals 15, x equals x, these are all identities, which means infinitely many solutions. And finally, obviously, if you come up with x equals some number like 1 or y equals 3, these all have one solution. Have a great day.